Alrighty, here we are on lesson 13, changing scales. And if you look here at the opening exercise, we are back to our scale factor. And it says the length in the scale drawing over the corresponding length in the original drawing. So if you want to just shorten it down, you can say that this is always scale over the original, right, which is also the same thing as part over whole. Okay? So make sure you have that down to help you out. The next question says, describe using percentages the difference between a reduction and an enlargement. So for a reduction, remember it used to be that it was less than 1. But if we're using percentages, that means it has to be less than 100%. 100% is 1. So for an enlargement then, that means it must be greater than 100%. Okay? So in our first example here, we have, it says, use the two drawings below to complete the chart. Calculate the first row, drawing 1 to drawing 2 only. So drawing 1 to drawing 2 means drawing 1 is going to be our original, and drawing 2 is going to be our scale. So remember that our scale factor is scale over original. So if we're looking here, the horizontal distances, so it's scale over original, which means we would have 3.92 over 2.45. And when you divide that in your calculator, you get 1.6. Right? If we do the vertical distances, that means we would have 2.4 over 2.45. And when you divide that in your calculator, you get 1.6. So if we're going to write it as a percent, we have to move our decimal 2 times to the right, so we get 160%. And it asks us, is this a reduction or an enlargement? And we know because it's greater than 100%, this is an enlargement. Okay, so we're going to go ahead and do the other one. If we go from drawing 2 to drawing 1, that means that drawing 2 is now our original. I'm going to do it in orange. And drawing 1 is our scale. So that means all of our calculations are just going to be flipped. So for the first one, we'd have 2.45 over 3.92 now this time. And when you divide that, you get 0.625. If we flip the other one, we would have 2.45 over, oh, I have the wrong number. Just kidding. I just realized I made that mistake. We would have 1.5 here. Let me erase that. That means our other one is incorrect too. That's okay. Eraser. Erase this here. Let's try this one again. Instead, we would have 1.5 over 2.4. And again, you would get 0.625. And if we change this to a percent, this would be 62.5%. And because it's less than 100, that means that this is a reduction. I'm going to go back up here and change. I wrote the wrong number down. For this one, this should be 2.4 divided by 1.5. There we go. Okay. So, and as you see, when you divide them, you should get the same number for the decimals because that means that it's actually a scale drawing. If you get 2 different decimals, A, double check it in your calculator, make sure you plugged it in right, but also that means it might not be a scale drawing. Alright, go ahead and flip over to the next page. Example 1 here says the scale factor from drawing 1 to drawing 2 is 60%. Find the scale factor from drawing 2 to drawing 1. So if we do our original, and what they gave us originally, that means drawing 1 is our original, and drawing 2 is our scale. And that means that this is our original, this is our full 100%, and this would be our 60% if that's what the scale factor is. So if we were to flip it around and make this one our original, they want us to go the other way now, and this one our scale, we're going to keep our numbers, but just remember that it's always scale over the original when we find our scale factor. So that means we would be doing 100% over 60%. And if we put that into decimals, we would have 1 over 0.6. And when you divide that, you get 1.6 repeating, which as a percent would be 166.6 repeating percent. So that is our scale factor. Alright. Example 3 here gets a little more tricky because now we have 3 pictures, we have lots of arrows and numbers. So if you read it, it says the scale factor from drawing 1 to drawing 2 is 112%, and they have that on our arrow. And the scale factor from drawing 1 to drawing 3 is 84%. Drawing 2 is also a scale drawing of drawing 3. They have that arrow, but it's blank. And it says, is drawing 2 a reduction or an enlargement of drawing 3? So let's do that first part. Is drawing 2, which is right here, a reduction or an enlargement of drawing 3? And we can see just by looking at it that it's an enlargement. Alright, and now we have to justify using our scale factor. So drawing number 3 is going to be our original because we are going from 2 to 3. And drawing 2 is going to be our scale. Alright, so if we do scale over the original, we would have 112%. We're going to take that from our first one, over 84%. And when we rewrite it as decimals, we'd have 1.12 over 0.84. And when you divide that, you get 1.3 repeating, which as a percent would be 133.3 repeating percent. Okay, so I know that is a little tricky, but the next part says explain how you could use the scale factors from drawing 1 to drawing 2 and drawing 2 to drawing 3 to show that the scale factor from 1 to 3 is 84%. So now we're kind of doing the same thing, just in a different order. So I always like to write it out first, just to help us out a little bit. So from 1 to 2, we know is 112%. From 2 to 3 is 75%. Alright, and we are trying to figure out how to get from 1 to 3 now. This is the one we don't know. So that means we're going to use what we do know, and we are trying to figure out from 1 to 3, so that means we are going to find 75% of 112%. So if we were to do that, we would multiply 0.75 times 1.12, and when you do that, you get 0.84, which would give you 84%. Okay? So I know the whole arrow thing is a little tricky, but we are going to go over it in class some more. We're going to do the whole next page together. So just bring any questions you have with you to class.